Hello and welcome to Identity Office Hours. I'm your host, Mike Schwartz, and this is episode 116. And the topic today is Replays Rejected, Fortifying Microservices Against Stolen Tokens. And our guests today are Mert Kaskuner and Naveem C., two engineers from Yahoo. Welcome, guys.
Thank you for having us.
Thank you, Mike. Thank you for having us.
So before we dive into this, maybe we could just get a quick background. Mert, we'll start with you in alphabetical order. What brought you to Yahoo? How did you end up on sort of this career trajectory?
So I was a software engineering graduate, but my career started as a penetration tester in cybersecurity consultancy company. And I spent several years doing a consultancy work in cybersecurity. And then I thought, I need to see the other side. So I joined an e-commerce unicorn in Turkey. Then I spent some time over there as a security engineer and thought to myself that I need to see big tech because e-commerce within Turkey with 35 million customers was a big undertaking for someone like me who was a part of a 5-man team over there, which by the time I leave was 35 to 40 people. So I joined Amazon and moved to Ireland, and I'm still in Ireland. And that's how I end up in Ireland and working for Amazon. And then I moved here to protect consumer identity as a product security engineer.
Awesome. And Naveem, how about you?
Yes, Mike. So I have close to 20 years of experience. Initially, when I started my work career, it's with HP, Hewlett Packard, and as well as Robert Bosch after that. Both of them is nothing related to identity. It was building some tools for automobile related stuffs. And then after that, I joined Yahoo, I think 15 years back. When I joined Yahoo, I had no clue about identity and any of the stuffs related to identity. But after that, started working on identity and started loving it. So I decided to stay with identity and start exploring more on it. So from 15 years, I've been working on many stuffs in Yahoo, include all the flows like login, registration, account recovery, even standards like OAuth, OpenID, even some of the partners we have integrations. We built integration to manage the user accounts. So overall, it's been a pretty good journey in Yahoo. And at the same time, we have been learning new stuff every day. And yeah, we need to be ahead of the frosters, and keep improving and building new stuffs as well as solve some of the existing problems. So it's been a challenging and
One quick follow-up question. Yahoo has a lot of great engineers. We're trying to get Jeff Corrigan on, hopefully sometime in the future. But just how big is the team? Like just in like broad numbers, like how many identity engineers at Yahoo build and maintain this great infrastructure?
So we have close to 80 people. This includes identity as well as we also have a privacy team, and there are multiple teams within our org. There is identity, privacy, and as well as mobile apps, SDKs which we build it for identity, and we have a user data store because we need to maintain the data of the users securely. So there's a separate team which manages the sensitive data of the users. So including everybody is 80, but I'm not sure. I need to check how many engineers specifically working on identity.
Yeah, that's pretty amazing. Well, let's pivot to the topic at hand. And Mert, I want to start off by asking you to describe the problem that you guys were facing with the existing security. And if I can, actually, maybe can I show the first diagram before I ask the question? We have this diagram. Let's see. And so the way that I read this diagram is, we're trying to prevent basically stolen cookies from being presented. But Mert, maybe you could walk us through what was the problem that you set out to solve?
Yeah. So our initial quest question stemmed from how our cookies are flowing through within the Yahoo ecosystem. So when, as a user, when you visit Yahoo and you create an account or you log in, you get a cookie. And when you do different things within the Yahoo ecosystem, that cookie eventually ends up in our infrastructure. And since there is no other different model like the transaction token we have today, as a service, you only have a cookie to make a request for the user to ask something else. Like, let's say you're on the homepage for looking at news, but you also have a Yahoo Mail and you might have a notification, which we need to show it to you. And for that to happen, that homepage service needs to ask about like notifications, maybe some other news that you're following, and it needs to show you, for example, from a finance that like the stock that you're following is actually going up or down. So for those things to happen in the backend in our infrastructure, like they are using cookies to ask data from each other. So this was our initial question, meaning based on this. The question was like, how can we reduce cookies going around internally?
Right.
Because
I have a quick question about the cookie. Is the value of the cookie assigned JWT?
but Naveen can explore further, but like we have basically a cookie, multiple cookie values.
Uh-huh.
Some of them are encrypted, some of them are not, and those cookie values are like being used. Like for session, we have one as well within the cookie field, but we
Right.
have other things as well. Like since Yahoo is a node company, we have different things for different
Right. So is
use
this
cases.
cookie an encrypt? So the encryption is a trust model. So it's an encrypted piece of JSON basically, and you can trust this because you can decrypt it. So is it just because it sounds like I'm just guessing that the payload of this cookie is probably JSON. Is that true?
Yeah, it's been a long journey. Like when Yahoo started, I think I'm not sure whether JWT concept was there. So I think that time, like it was mostly encrypting some of the cookies, and then when they decrypt, they used to validate. But eventually, we kind of enhanced those same set of cookies. It's not JWT, but some of the data we have. Signing with the private key and we validate with the public keys. Yeah, so it's kind of a data which we need to kind of it's immutable data which we have in the cookie that ensures that nobody tampered the cookies.
Right.
So yeah.
I see. Um, and so what the attack we're talking about here is you're basically saying, I don't trust this browser. Rather than the browser sending me something, um, what I would rather do is, and let me go share a different diagram, is um, I'm going to show, actually, maybe I'm going to jump around and just show the solution here. Which is that instead of allowing the attacker to send the cookie to the backend, basically we have the content distribution network, or the CDN, use transaction tokens here, or exchange basically the cookie from the browser for a transaction token, which is what you're saying is basically only accept transaction tokens here, don't accept the cookie anymore. Is that right, Mert?
So when the world I was talking about internally, where we had cookies, services were expecting cookies, but
Yeah.
right now since we do the exchange, I think in
Hmm.
here like user Yahoo and CDN part needs to be cookies, and at the CDN we do the exchange. So
Yeah.
cookies would go and transaction token would come in, and the internally services would only recognize transaction tokens. So this would prevent situations where cookies or the information that within those cookies are going around everywhere internally. Instead, you have this token which is valid for a certain amount of time and has certain amount of scope, and it still has the data that cookie has, but in an encrypted format. So that means if I'm an attacker who sits on the internal network in any of the services, looking for a cookie, I will not be able to get one, because instead what I would get would be something like a transaction token, but I wouldn't be able to use it because our CDN expects cookies so that they can switch that to the transaction tokens. So that effectively for us eliminates certain types of vulnerabilities where we might have an attacker inside, rather than the external use cases where we have different checks for those. But our main use case for this was like, how do we prevent cookies going around internally? How do we prevent if someone is listening within Yahoo network for cookies and sensitive data? And we specifically thought about that problem.
Yeah, and I think just a clarification here. I think there is a typo here.
That is a typo.
Yeah, instead of transaction token coming from user, it will be cookies coming from user, then to Yahoo, and then to CDN. It's cookie, and then it gets exchanged to transaction.
Yep.
Okay, I wasn't even looking at that part.
Yeah,
I was mostly
there was
looking
a
at this
typo.
part. But yeah, you're right. This would be the cookie, or
Right.
you know, there's an interesting question about whether you should send the ID token or the access tokens that the user obtained upstream. So it's clear that you should send the access token because that's the token issued to call an API. But I think a lot of people go back and forth on whether you should include the ID token, which has an audience of the application. But it sounds to me like you're saying, let's actually, can we jump ahead and take a look at what this transaction token looks like at the payload? Let's try and let me play screen sharing. Apologies, this takes me too long. So this is the payload. Naveem, maybe you could walk us through this. And this isn't exactly the payload. This is just sort of like a close approximation of the payload. Right?
Yeah. So here, subject identifier is the user identifier. Internally, we use something unique identifier for each account, and then TXN ID is a unique transaction ID. Every time when there is a new transaction token gets generated, we will have a unique transaction ID so that even the downstreams can log that ID so that we can kind of capture the end-to-end data or the request where and all the request went in, and as well as we can create a consistent audit trail or the funnel across the board, because we have multiple services managed by different teams. So having this unique ID will help us even the debug and as well as creating some kind of a audit trail across the board. And then authorization context is something which we need to kind of pass it to downstreams. So some of the downstreams need some of the basic user information like uh, ID token claims like a first name, last name, and some of the internal stuffs which we have within Yahoo. So those are minimum data they need. So just for this, they don't need to call our user data store to fetch. So anything which is common, which we can put it here, we'll have it in an encrypted format. The secrets are granted access only to the services they really need this data. Otherwise, we don't even grant the access to the secret.
If I could just interject for 1 second. I sort of jokingly put in ID token there. It's not really the ID token. It's a bunch of claims about the user. I make the joke about ID token because it also includes details about the authentication event, like when the user authenticated, how they authenticated, and other metadata about the authentication event itself. So it's sort of like an ID token plus claims plus user info token plus some other enterprise stuff. I'm sure that you're putting in there.
Yeah. So just to add an example, so whether the user solved multi-factor authentication to have more trust, and also we are building some stuff where we also have a authentication score. We can add all those things inside the authorization context so that downstreams can understand how the user logged in, or what are the details of the login event.
And that's interesting because you're differentiating between perhaps a scope author that's specific to the user, and a scope that's maybe specific for this transaction token, and those could be different.
Right.
Yeah, because not everyone needs those data. So it's like with the cookie world, we had those within the cookies. Not everything that we put here, but like the majority of them were in the cookies. So you would get them, and you would be able to read them because they are there. But right now we are encrypting them, and since you need to request access, it's gonna be a like trail of like things you as a service requesting access, providing business justification of why you need that data and why you need to decrypt it. So it also limits, again, if from the internal threat perspective, if someone sits in your infrastructure, listens to your logs and events, it will not be able to see that context in a limit. Like it can see still if they happen to end up in a service where it decrypts that, it would see, but
Yeah,
it reduces that attack surface
right.
overall.
So you're saying that this is
Encrypted data.
encrypted. Yeah. So unlike and JWTs could be encrypted also, of course. But yeah, this is importantly is encrypted because if it's like you said, if it somehow ends up in a log, you don't want it leaking any data, any PII or other security data. Interesting. So in terms of validating this, and I just want to make one point about. So we looked this up in the RFC, and there are some standard claims in the. Let me see if I can find this. I think this is it. Yeah. So there are some standard claims that are defined in transaction tokens. Now, of course, this transaction tokens is not final yet, and is also might have been written after you guys implemented this.
Yeah.
But they defined, I think it was, so you used TXN ID, and then in this spec they use just TXN.
Yes. Yeah.
Um,
So
also, they
have a background. So we started, I think, way before this RFC work was started. So it was like uh, 5 years back, more than 5 years back. So when
okay.
we started the work, I think the RFC was not there. So we implemented based on whatever we wanted to build. But now we have this RFC. Once this is final, we will try to adapt it internally.
Yeah. Okay. That's interesting. Yeah, and there's some other claims here that could be validated, like the audience claim potentially could be validated. Um, and Naveen, you mentioned something interesting about. Oops, I'm trying to stop screen sharing. I just made it worse. Um, Naveen, you mentioned something about also publishing libraries for developers to validate these transaction tokens. Why was that even necessary? And then what is the breadth of like the libraries that you now need to maintain?
Yeah. So as Yahoo has multiple products, Yahoo Mail, Sports, Finance, we have a lot many products and managed by different teams. And each team have their own languages: Java, PHP, C++, and all. So we, like, when we build this like a transaction token service, after transaction token service is one team which mints a token, but
Yeah,
validation is local. Anybody can do a local validation reading the public key. But we didn't want to kind of add a burden to each team building their own validation, and we need to kind of make sure they are building it right, or they are validating it right. So instead of that, we made it easy, where as a identity team we built libraries for them, so that they can just plug and validate. So we have multiple languages: Java, PHP, Node, and C++, etc. So based on whatever languages they are having, so they can use the library. For us, validation, since it is more of a durability validation, of a headache to maintain those libraries. There's not many changes happen. But yeah, it's easy to maintain by one team versus like asking everybody to change whenever we make changes. So that's our thought.
So Mert, when we say validation, do we mean we're validating the signature, we're validating the expiration to make sure it's not expired, um, and I understand you're not supporting revocation yet, but any plans to maybe support revocation? Because OAuth has this OAuth status list that to enable you to revoke. Um,
Yeah. So for our context, I think we have, so for validation within the cookie world, when we do the exchange, we have a validation in a sense that we validate the session and whatever is necessary to make sure that that cookie is not tampered with, along with the fact that we need to also make sure that it is not a fraudster who's trying to log in or trying to use that cookie or session. So as part of our validation overall, we have that as a first step on the CDN level. When we do the exchange, our service for transaction token service do those checks, so that by the time the transaction token is issued for 5 minutes, at least you can be make sure as an internal service that if this token is issued, it means that there wasn't any fraud going on when it was being issued.
so you're doing fraud detection in the CDN level, and then the transaction tokens and artifact you get after you've basically gone through that process.
Yes, so that would guarantee that like transaction token service validated the cookies, validated the session, validated the user authenticity as well, and
Uh-huh.
produced this token for CDN to send it to the downstream. So as a property, you only have one obligation at that point, which is the validate the JWT itself.
You're simplifying it a lot for the developers,
Oh
but
yeah,
you're saying, but it's not simple enough because you still have to give them validation libraries.
oh yeah, but like in the current world, like not current, but in the world where we were using cookies internally as well, as a
Yeah.
service, you needed to call the, which is now transaction token service, to valid, to make sure that cookie is valid and not abused yet.
Mm.
Because like that, let's say you have a service and you're calling some other service, you need to make sure that cookie is still valid, because there might be a revocation happened. For like, for example, we might have, as security team, we might have flagged the account for abusive behavior, or
Hmm.
maybe that account is taken over and we were taking action by the time that service is calling any other service with that cookie. So each service needed to call the now a transaction token service, which we can call it in this context cookie service. Before, they were calling the cookie service to make sure the cookie is valid, not compromised, and
Mm.
not anything going on with that cookie
That
or
sounds like
session.
a long round trip. A
Oh
network
yeah,
round trip is not very efficient.
yeah. So right now, CDN is doing that with the transaction token service, and as a property, you only have one application, which is like use the library we provide to make
Mm.
sure the JWT is not tempered and valid.
So that sounds like a pretty big improvement because you had all of these backend services calling the cookie validation service, and you basically cut those all out by issuing a transaction token and then just saying you could locally validate it. Is that right, Naveem?
Right. Yeah. So as I mentioned earlier, for each request, there are multiple downstreams or multiple microservice calls which happens. Previously, without transaction token world, all of them used to make a remote call to key validation service where we used to do the validation, and each downstream need to make a remote call which adds additional latency on each hop. So now with the transaction token, it only happens only once on the CDL layer where it needs to call a transaction token service for exchanging it for a token, and then after that all the downstreams they can just do a local validation and there is no additional network latency. Yeah, that's a big improvement with respect to network latency there.
We discussed this a little bit before the show, so I'm going to put you on the spot. What do you think about the idea of moving token validation into the PDP, a local PDP?
Yeah, as I said, like we wanted to kind of build this in the beginning, or then we built it, but now we need to kind of think about how to build it in kind of a more of a standards way, whether it's a PDP or the RFC world. So kind of we need to kind of look into that aspect as well. For now, yeah. So initially when we started, like, yes, we have multiple teams. We have to work with each of them to kind of convert it. So now we will go back and try to kind of see how to improve that.
Uh-huh. So Mert, the transaction token um, gets minted as a result of a token exchange normally, or at least this is how it works in the spec.
Mhm.
So in that token exchange, it sounds like it's a good time if you want to enrich that transaction token. You could potentially put any claims in there.
Mhm.
Can you talk a little bit about what are the thoughts about what types of claims might go in there? And is this really your chance to do all that token enrichment? You can leave the whatever existing stuff is there and now mint this new token and have the flexibility to put in whatever claims you want.
So for the scope, it's either done scoping or keeping the same. But for the claims, especially with the uh, extra information we have within the cookies or
Mm-hmm.
the other information that properties might need, we are essentially bundling them in as a authorization with what we call authorization context, but you can call it like user bundle basically, which might also have related to cookie fields that was related to users and can be used by the internal services. So I think, like to your earlier point, by putting them in here in an encrypted fashion, like makes us also like, so let's say I'm an attacker and I'm trying to figure that out. So encrypted field ensures that's not gonna happen. It also ensures like if you're a property and do not need any of those claims, you can just like validate the library and move on. But
Hmm.
if you need them, you can ask for the token that to decrypt that field and get whatever you need, which is going to create an audit trail for us to make sure like who's accessing those claims. I think you can see it as a like scope for the internal services, because like we also effectively have a way of auditing who's accessing and how they can access to those user fields or that claim that we put over there. And effectively we can put multiple things over there, like maybe Naveen's previous example is relevant here. As the consumer identity side, we can provide a additional context for the user saying that, hey, this user is a trusted one because they have a high score, and maybe they are using passkeys, maybe they have multiple factors already solved as a challenge. So we can provide those signals within those claims as well for the downstream properties who would like to use them as a additional method, because like we have finance, we have mail, so they might have certain flows which may like take user through a certain like critical actions for the user account or user themselves. So they can use those claims to make decisions basically on like maybe they can say that, hey, this user has a relatively low score, so why would we not do a step-up authentication, for example, or maybe we can throw additional second factor challenges based on those signals that we provide.
Right. I like the way this is going. I'm going to reshare the token claim again. Um, this is we're breaking the record for the most screen sharing on an IOH live stream, because I normally don't like to do it, but in this case I think it's helpful. Apologies to the audience if you're looking at this on your phone. But it's almost like you're talking about two different things, because in this authorization context here, um, we could filter the claims, is what you're saying. So maybe we don't want to send all the user claims to a certain application. So we get a shot to either add claims into this user authentication context, or maybe take some claims out even. And this might include security information, like entitlements, for what services you're getting, or what subscriptions you have, stuff like that.
Mm-hmm.
Um, but then there's also, these other claims, so we have in particular the scope claim, but potentially, we could add the dolphin claim. Um, So we can add in whatever claims we want here, and 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 as you mentioned, it sounds like then an application that's consuming this transaction token might not even care about this encrypted part. Its policies might solely be based on the payload of the transaction code token, especially if it's a workload authorization. Um, Naveen, any thoughts about how you see other domains or your own domain sort of managing the schema of what goes in here?
Yeah, so like a little bit of history how we started. So we wanted to understand what our downstreams needed. So based on their need, we kind of understood whatever data we need to put in. We kind of created a policy what goes in. There are some data which is property specific. Say um, some data related to mail or a sports or a finance profile details, we don't add them here because this token passes through multiple layers. Like it goes to mail, sports. If the transaction needs to go in all those services, the cross property should not read the data. Say mail related data should not be read in sports, vice versa. So we have a policy and to review, or we have a kind of a config what goes in this context based on the review. We only put the account level details, whatever is needed. Yeah, that's how we maintain this.
Okay, so you don't see a lot of basically adding your own claims.
Uh,
These are the claims, and that's it.
yeah.
And this is
So
very tightly managed.
yeah, we also have a service, the transaction token service. Also, we used as a data service where they can even make a call if they need additional data related to say sports needs additional data. They can make a remote API call by passing this transaction token, requesting whatever the additional data they need. So that service manages all the authorization and whether that data can be sent to sports. All those configs are part of that service, and so that is a separate authorization
And
done.
that's also where the security logging happens.
Yes.
So that's also where when in the cookie world I was talking about validating the cookie against the abuse as well. So with this as well, when you we hit that service with the transaction token, we do the same for the transaction token as well, because we want to make sure even within that 5 minutes time frame, if you would like to call that service for any other additional user information, that service is going to look into the who user are, and then we'll check if that user is actually compromised or session is revoked or anything. So it might deny you access if we flag that account as compromised, or for example maybe low score, abusive or something. So even within that 5 minutes, if you happen to hit that user database we have, it will be checked against the same procedure when we were issuing the token.
So it has what you're saying is that it has there is a validation service, but it requires that you do a network call round trip in order to use it. So it can't be done locally to check like if a transaction token has been revoked or let's say or flagged or something.
So you can do that by calling that service. Yes.
Yeah. So it's a round trip.
Yeah,
Round trip,
if you
that
want to make
gives
sure.
you
Yeah.
the assurity that this hasn't been. If this is a high risk transaction, you can afford the 2 millisecond round trip to do the validation.
That might be a use case. Yes.
I wanted to show, one more diagram of a slightly related attack that we talked about, and this one, the cookie isn't stolen, but maybe it's misconfigured. Naveen, could you talk about why this is slightly different, or the same, or what it's similar? What are the similarities too?
Yeah. So here misconfigured service. So basically, if so, Mert, can you speak more about it?
Yeah,
Yeah.
Mert, sure. I'm trying to switch back and forth, but
Mhm.
Yeah,
um, but
Mert
but
has
I know you guys gave different parts of the conversation. So Mert, I mean, why is misconfigured different than stolen cookie? I guess is the question. Why are you showing that as a separate use case?
So in here, we wanted to highlight, since with the transaction tokens, we only accept transaction tokens internally. In the internal world,
Hmm.
we don't have cookies anymore. So
Yeah.
if you happen to steal a cookie, you can, well, in this context as well, you can still use the stolen cookie to log in into Yahoo.
Hmm.
But it would be like internally, you would go to the yahoo.com, maybe you would replay the cookie and you would log in. But let's say you have the cookie and you happen to find a misconfigured service for the within the Yahoo ecosystem, and let's say it's an internal API that we can only call, and it's happened to be misconfigured, and or maybe you found a server-side request forgery vulnerability, and you are able to call other services. So in that context, if you happen to provide cookie with that request as an authorization method, or like authentication method, I would say, it's not gonna be get accepted, because like the internal services do not know what cookies are anymore.
Yeah.
They expect transaction tokens. So even if you find a cookie to abuse some internal endpoint that happens to be either public or maybe through some other vulnerability, you will not be able to do that, because those services are not accepting cookies anymore.
Right. So basically, wider breadth of like how this not using cookies helps you.
Yeah,
Um,
that's it.
Naveen, I don't know if you talked about this in your live stream, but any thoughts on like has this been effective? This strategy?
so yeah, like in the past, we have noticed, say some of the services were not making a validation, proper validation, and also when the cookies were passed. So there are some services where we even log those cookies in those services, like while debugging, we ended up logging, and then we like I went to production where the cookies were there, though they are not compromised, because
Yeah.
there are a lot of internal threats. Somebody can take the cookies and put it in the browser. So, and it's hard to differentiate the request coming from a real user or from the stolen cookie from
Yeah.
somebody's browser. So yeah, so all those cases, even if we end up logging the transaction token with the misconfiguration, those
Ah.
those cases will not happen now, because the like tokens cannot be played from outside. We don't accept the tokens coming from external service or even browsers or apps. So those cannot be used. So yeah, it will be
Interesting.
effective, yeah, if you use this.
Um, and at a high level, since you've gone to this pattern, have you been able to measure any decrease in attacks or threats? And Mert, you can answer this one too if you know. No.
Like for account takeovers, I think it is out of scope for this, so I don't
Uh-huh.
have the exact data. But for the specifically server-side request forgery vulnerabilities, I need to check. I didn't check it. I need to check, but like at least from my point of view and my recent experience, I did not recall any server-side request forgery vulnerabilities happened since we adopted transaction token. Maybe it's just by luck. I don't know, but I need to check more, like more diligently. But yeah, that's something that I did not check myself.
And SSF are one of the most pernicious and annoying as a security penetration tester. I'm sure you're aware. Um, pen testers all over the world are very disappointed that SSF is gone, I guess. Um,
It enables you to pivot into some other application internally if you are able to figure it out. So yeah, it's good to eliminate that type of thing. If like we before that, like it was a type of attack that we have to, I think, like make sure that we're not like, I think still it's a subject of discussion, but at this now the risk is significantly reduced versus how it was before.
Yeah, since we are reducing the risk vector, previously, when there was in case of cookie world, we didn't even know whether those were misused, because we were not able to differentiate the request coming from a browser or a real user or a bad actor. So, but yeah, we know it is better, and it will be the risk will be reduced. But yeah, it's kind of hard to differentiate the impact. Yeah, or I
Right.
think yeah.
Cool. So let's actually go into last thoughts. Mert, we're in alphabetical order, so I'm giving you for the first last thoughts. Any takeaways or action items?
Yeah, I think if you're a security engineer and you're thinking about how you can elevate your consumer identity security, I think there are multiple things that you can look into. So one is the device bound token, which I'm very much fan of. And the other thing I think is looking into transaction token to separate your logic between how you're dealing with your external world versus your internal infrastructure, so that like when both of them combined, like you can have a device bound token, and at the edge you can exchange it and bind it to a certain transaction with the transaction token, which I think would give you very much peace of mind when it comes to a lot of threats that we are dealing with within the consumer identity space. So I definitely recommend checking out the transaction token RFC, which is like I think led by George Fletcher. He's the big part of our journey as well. Thanks to him, we were able to also start thinking about these many years ago, which I wasn't even here. So
Yeah. So George, Atul, and others have contributed to that spec, and George, of course, was he affiliated with Yahoo at one time? I
yeah.
can't remember. Yeah. Um, and so yeah, it's been a journey. So Naveen, any last thoughts?
Yeah, just a continuation. Yeah, or like we started this work when George was at Yahoo. So George, Atul, and Peter are the editor of the RFC. Yeah, please take a
Peter
look.
Castleman, right?
Sorry.
Peter Castleman, right?
Yes. So you can take a look at the RFC, and there are a lot of interesting stuffs in there, and also there is a open source code which is built by Atul and team. It is called tokenities.io, like Kubernetes, tokenities.io, where you can have a transaction token service code, and also there are sidecars which you can use it for local validation. So those things are readily available, which you can use it as a from the open source code. Yeah, it's all there in the RFC Git repo. Yeah, feel free to take a look, and yeah, you will learn a lot there. Yeah, one more thing to add. Many a times we tend to ignore the internal threats. Sometimes it might be hard to detect those use cases. But yeah, if we have this transaction token, I think we are mitigating some of those internal threats. Yeah.
Awesome. So yeah, this is a super interesting episode. Thank you guys so much for joining us. Um, and I don't do a lot of product pitches, but let me do a quick one. That we actually implement transaction tokens at Glue. Well, in the upstream open source project, Janssen project, we just saw transaction tokens as another OAuth endpoint. It uses token exchange. We already supported token exchange, and we have interception scripts. Um, and so yeah, we're also on the transaction token bandwagon. We just see it as one more type of like token you might issue. We issue ID tokens, we issue access tokens, transaction tokens, UMA tokens, FIDO, authentication. We just see it as sort of one more JWT in this profusion of JWTs. Whimsy tokens soon, by the way. But I think that transaction tokens is interesting because you really could put whatever claims in it. You guys at the Yahoo teams, you picked your claims and you have a way to manage that. But there's a pretty broad variance. In addition to what standard claims, what other optional claims you might want to put in there. I thought it was really interesting how you're putting in the ID, basically the identity assertion and passing that along. So yeah, transaction tokens is really interesting. The Signal product or a tools product, Tokenetes, it's just if you don't want the whole big OAuth server with signing and everything, it's nice to have just like that little service that just does transaction tokens. But if you need to actually manage keys and deploy clusters and stuff like that, you might want a full blown platform. Anyway, next episode, a quick announcement. We have a real celebrity, Ken Huang, who's a cybersecurity guru, author, speaker, keynote speaker. He's really well known. And we're going to talk about something called the Agent Name Service Protocol. I'm really interested. I have no idea what it is other than the title. I read that he wrote a paper about this that we're going to talk about. Maybe it answers the question that Spiffy answers, which is, I need an agent identifier. What URI identifies that agent? And I think there's more than one solution. Anyway, we're looking forward to that. So please join us on Thursday. And with that, I will say thank you to the audience. Thank you, Mert. Thank you, Naveem. And we'll see you next time.